This is the last section we're going to go over, and it's about Pythagorean theorem. So it also includes special right triangles. Two ways to look at Pythagorean's theorem. It is a squared plus b squared equals c squared. It is also leg squared plus leg squared equals hypotenuse squared. There are two types of examples you're going to run into. And the first type of example, these are our special right triangles. We're going to get back to the other triangles in a second. The first type of example you're going to run into is missing hypotenuse. If you're missing the hypotenuse, which is a hypotenuse definition, quick definition, it's the side across from the 90 degrees. So you would take the legs, 4 squared would be A, 3 squared would be B, and then you set it equal to the hypotenuse, C. So then you end up with C equals 5. That is now the hypotenuse. The other type of problem you're going to get is one of these down here, these bad boys, because when you get one of these, you end up with, let's see if I can get this working. You end up with a missing leg in this formula, which is b squared. Same idea, but you're going to subtract 9 from 25 and get 4. These are special, called Pythagorean triples, because there's no decimals involved. Because if there were decimals, you would end up getting something that's not exact, but close. It's all good. If you have whole numbers, they just call it Pythagorean triples. All right, let's keep it going. Here's an example. Try it through. You end up getting C equals 10. C squared is 64 and 16. Here are the two specials. It's a 30, 60, 90 and a 45, 45, 90. I do want to talk to you about this idea, which is if you have a 45, 45, 90, the side across from one of the 45s are always going to be the same. And the way they denote that is they say the side across from that is going to be n, the side across from the other 45 is n, and the side across from the 90 is that number, any number, times the square root of 2. So 5, if 5 was the number here, it'd be 5, 5, 5 square root of 2. Similar idea, but not exactly the same, is going to be the 45, 45, 90 degree triangle. So side across from the 30, 8. Side across from the 90 is double that, 18. Side across from the 60 is going to be the side across from the 30 times the square root of 3. And that is your Pythagorean theorem section